How's it going, everyone? Roberto Gonzalez again. Today it'll be a very interesting video because we're gonna look at this specific thing called Thunk that is lay down the conceptual fundamentals of how can we now handle is concurrency in our async applications in this async programming. So useful, especially in today's world when you need to actually write these JavaScript applications that, of course, you at the end of the day not only is provide some interactivity to the web page, but also to communicate with external service or do tasks that will be complete at some point of your future. Make your program continue after a certain X amount of time, right? To be more precise. And that's what we're gonna focus in today's video. In this particular pattern, as a way to now, especially when we need to deal with this concurrency, all of these tasks that overlaps at a time, unlike parallelism in the context of computer science, which is putting several tasks or putting or execute multiple tasks at the same time by putting them all in one per threads. So with the concurrency is now having the ability that on a single thread, as new task appears or overlap over time, how can we now deal with that? And because we can use, for example, things like web workers that is creating a new thread of the JavaScript engine where we can now share its data across all of this JavaScript engine instance that we create. But again, this is not a JavaScript feature. This is for the web platform or the server. So the problem still remains. How can we now handle this concurrency? All right. Pretty much when you talk to your mom, if you're cooking and then your mom suddenly calls you and you want to also try to taste the food that you are preparing. Let's say you're preparing a pancake and some sort of salad, and then your mom suddenly calls you. So this is not parallelism, because true parallelism, cognitively speaking, is not true for humans, right? I'm not a neuroscientist. I'm just describing is what I can observe. However, true parallelism biologically is that there are several things that need to happen at the same time in order to me to actually speak here. So, because now by understanding is how can we now deal with this concurrency, and especially is that how your brain works when you need to write or plan this concurrency. The idea here is by looking at how your brain works, give you now some patterns when it comes to actually writing your asynchronous applications, right? So it all starts here with the callbacks, which is the way of how we can now start to handle this async application. And after all, this is the continuation of the code at some point in the future, right? So callback is something that is provided by the web platforms. And we look now that this is something that we can pass this code, give it, and after an X amount of time, I want you to now evaluate this, right? So one of the problem with this is that it is this notion of inversion control, where you have now the first half of your programs that you are in control, and the second half of that program that you are not in control. And as a way to express the continuation of this program at some point of the future, we use a callback. So we run the first portion of our code that we have in control, and then pass this second half to a callback, where now the control is inverted. So we put them in control, and how when our code it will be run. Again, this is just a definition that comes from Kyle Simpson, and the point of this is to recognize that this inversion control is, for small applications, quite reasonable, but as the applications grows and grows and grows, then you need to actually look at this particular model that calling themselves, or in this another file that is calling, and so on. Then you need to actually you need to make all of these jumps. So this is not something that it is easy to read. So you have to do all of these non-local jumps. And well, as a way to now not only highlight this problem, and also another problems associated with callbacks, which is they are not reasoned about, especially if you have now several callbacks or several values that depend on each other's, okay, or these time dependent values. That's why you have now this callback hell, right? When you need to actually understand how that things work, especially when you read that code, because at the end of the day, JavaScript is a single thread, so you can make sure that after the line is executed, you go to the next one, you go to the next one, you go to the next one. But when it comes to asynchronous programming, things getting very, very weird. And one of the things of this callback, which is this particular tool that allows to do what we need to, is that when we need to defer this code, especially when we need to do that with multiple code, or when we need to wait for this value to get here and then do something else, and once you wait for that data, then do something else, we actually make a very interesting exercise as a way to see how is these things work. This is the solution. Let me put it here, the solution here. What? Okay. So, because this is a common pattern, especially on UI development, that you need is to perform several tasks in parallel and then waiting for them to come back. You need to perform several tasks in parallel. You need to wait for them to come back. You need to respond as soon as they come back, and find a way to organize all of this response in order. So, sorry. Storm is coming for real. Today was a very beautiful day. Yesterday was a very, very beautiful day. Today is like, what? We live in Sauron. Okay. Exactly. So this is one of the things, especially that we look at this, is like when we need to handling this particular asynchronous operation, we can do that with using plain JavaScript, and this is just an example of how can we do. The TLDR of this example is that once this AJAX operations needs to happen, we need to somehow is to order the sequence, okay? So we need to is keep track of all of these response, so coordinating all of these response, show them in order, and waiting for them to come back, and process them as it comes in. In other words, we need to have a record here in our map or in an object that allows us to keep track when the data is arrived, all right? And because this data can be arrived at any time in future, okay? We need to actually is show them in the proper order, right? So here we just fix this with the files, all right, because we already know what is the files here, but we actually need to go through this particular code, which is again not nice. It do what it's supposed to do, but we need a better pattern to handle this, or at least a pattern that by the time we run these applications, we can now get the data out of this, right? Remember, the whole point of this is to look at how can we now handle these async operations, okay, using callbacks, and how callbacks now is not a proper tool, especially when we need to handle is this more and more complex JavaScript asynchronous environment, or these more complex asynchronous environments in this JavaScript application. So that's a good thing, at least to recognize. Now that at the beginning I didn't have the ability to even describe this. It's like, what in the F is this? I know that I have to some sort of record as a way to now keep track of all of this response, but I didn't know how I'm going to show that. So by using an array and fix them in the proper order, all right, as they arrive, or fix them in this case, so as you're populating all of these records, all right, if this records or in this case, if this response actually in the table now are in order, so you have the file 1, the file 2, the file 3. If it's not, then you need to get out of this and check that again. Wait for that and check that again, right? So anytime you make an async request, you need to actually check if the registry contains all of the data. If it's not, get out of this. So wait for the second request and check for the response in that data, if that is in the proper order. If it's not, do that again until you get all of this parallel asynchronous nature, or dealing with all of this response. When you deal with all of this response, so when they are done. So that's very interesting, because the idea of this is to see that we have to do a lot of things, and even though the things work, it's not reason about it. It's not reasonable, right? Especially when you need to do all of these non-local jumps. And also remember that at the end of the day, JavaScript is a single thread programming language. It's evaluate line after another. So this was a very challenging problem, which is something that with async and away is something that you can do much more easy. But this was a very real thing 10 years ago or 20 years ago, where you say, hey, how can we now handle this asynchronicity, especially when you are building an e-commerce, and after you made out the checkout portion of that e-commerce, you suddenly realize of using a third-party library, a utility, that actually is, you take a look at the documentation, you implement that, you hopefully wait for now that work as expected, all right? You run the test, you push that to production, and that's it. 6 months later, after a cafe with your friends, then you receive a call from your boss saying, hey, there is a crisis here. I don't know what happened. We charge is Kanye West for 6 times the same TV, and now he's complaining about it, even though that we can actually reverse that on the payment gateway, Visa, MasterCard. Is actually posting all of that in Twitter, so this is a pure nightmare. So please get your ass ASAP, right? So yeah, he's not as casual self he was. So because of that, you take a look at the code, you analyze that, you reach to the logical conclusion that your code is not the one that is causing that problem. However, when you take a look at that third-party utility function, you dive deep into this, and then you don't know what certain things are doing, especially in handling is this responses. And even though that you take a look at the documentation, there's nothing there talking about this, and then you communicate with their security with their Jesus, oh my God, with you communicate with their customer support. And then you explain the situations, you tell them, hey, this is something that is not even documented to that. They're going to, then is when they're going to elevate that request to their developers, and by the time they do that, now you want to actually fix this, right? So then you say, hey, let me now put a Boolean flag here when something wrong happened, right? If the response is not ready, so let me put this Boolean here, right? So you think that you solved that particular problem, right? You actually run that test on the QI, right? And then the QI team says, hey, right, but what will happen if we, instead of passing now a callback, what will happen if that callback is never called, right? And then he or she started to asking more questions about that, and then expose you that this particular nature of this asynchronous stuff, especially when we have to pass down this code, and we hopefully get that data to be triggered not too many times, not too often, so not too many times, not too, even though that I put in here, okay, which is exactly, it's like not too early, not too early, not too wrong. So it always reveals this assumption that you're putting, especially when you're handling and using is this timer, this request that you're emitting. It's like, hey, not too early, not too late, not too many times, not too few times, no loss of context, no shallow errors, and the list go on so on. Especially with the not too many times. So, all right. So now that we described that particular scenario, and the thing that the discipline that we need to do here, especially as a way to now solve these problems, which will be the next level of competency in JavaScript, especially for handling is this asynchronous scenarios, and how you, in my case, actually I'm doing this as a way to be much more a professional about this, which is a very interesting word, a profession, which is this is come from Old French profession, which means like secret vow taken upon entering a religion. In this case, this is not a religion. You might think that this is it, depend of your point of view, But this is now secret value that you're taking to actually is now build, design and maintain JavaScript applications, right? So that's why we're looking here at these particular patterns as a way to understand now is how do we get here, specifically here. So some of the old patterns that have after the callbacks is, hey, let's go to now is handle is to or passing is two callbacks here, right? So let's go to pass now these two callbacks to try something, and well, let's go to now run that callback here. So that was thankfully that was not approved, because now as you can imagine is that how do I make sure that this callbacks actually runs at with the proper thing, and how do I know now that the first callback that I need to pass is the okay and the second is the error? What will be, which callback will get triggered first? So in any case, it's like, okay, that's why we jump into the next one. We will say, okay, now let's make now is one single callback, and by the time they get that data, all right, now you can so you're gonna expect is the first parameter is the error, or the second is the num, right? And this is a pretty standard way of how now back in the old days this particular code actually worked right now. And the other is that this is great for example handling is asynchronous callbacks, error first style. But what happens when we need to do this with nested callbacks, right? So after the value we get here, we need to actually call that try something, all right? And that's why we have now this nested callbacks function. So one of the downside of this pattern, okay, is that this code is not that this code is not that awful, but it requires you to jump is to the code. This example is just something simple, all right, but this will require you to jump to the code to place to other models here. So now you're doing all of these non-local jumps in your code, which of course is much more cognitive burden. It's a cognitive load. All right, so what is the next pattern, right? Okay, as a way to make our code much more understandable and reason about it, because this code is not right now somehow sequential, right? So that's why we look at thunks, and thunks is something that predates JavaScript. Okay, I don't know where the name come from. I don't know what they're smoking, and I would like to have some of it. But we can describe now thunks fairly kind of deceivably simple, right? Is that from the synchronous perspective, a thunk is a function that have everything that it needs to do and give you a value back. So is this just a wrapper, a function wrapper that anytime you call that, it will give you now the value. So you can think of this now as a token, as a container, a portable way of how you can now is get this value, access to this value anytime in your application, right? So from the asynchronous perspective, so a thunk has everything that it needs to do is a wrapper. Okay, a thunk is a function that got everything that it needs to do, except that it accepts a callback to get the value out of this. And this particular concept is very interesting because this is now laying down the foundations of what we know about with promise. So again, promise is just a more complex. So promise is just handling more complex scenarios. Thunk doesn't solve the problem of inversion control, which is you need to actually go to another one. But this is huge in terms of isolating time from the consideration in our code. So anytime you want to isolate the time from your consideration in your code, this is a good particular pattern as a way to solve this, right? So far so good. So my program here, by using it as an async Thunk, I don't even need to or care when this data came from or where this data are coming from. I don't need to know or care when the data will be available. I just only care that will be by the time I call the callback. This is something interesting because now Thunk lay out now as the foundations of this specific concept that is using Redux RTK. So for example, Redux toolkit like React RTK query. Okay, so if we take a look now here at this RTK query, okay, like that, right? So RTK query actually is now using is this Thunk, right? So as you can see here, so that means that Redux has never included anything built in to help solve the use case. The Redux does have taught some common patterns for dispatching action around request lifecycle to track loading state and request results. And Redux Toolkit create async Thunk was designed to abstract that typical pattern. It's like, hey, how do we now keep track of the life cycle of a request? We're just waiting for a request to be loaded here. I don't know when that happened. You just only care that, and by the time that happened, then I want this to update the state in my application, right? So was designed to abstract that typical pattern. However, users still have to write significant amount of Redux logic, which is the update state logic, to manage the loading state and catch the data. So over the last couple of years, the React community has come to realize that data fetching and catching is really a different set of concern than state management. And I think they realize the hard way. Well, you can use a state management libraries like Redux to catch data. The use cases are different enough that it's worth using tools that are purpose-built for the data fetching use cases. RTK query takes inspiration from other tools that have pioneered solutions for data fetching like Apollo clients, React Query, URLQL, and SWR, but adds a unique approach to this design. The data fetching of catching logic is built on top of Redux logics. Redux Toolkit creates slides and create async Thunk APIs. Because Redux Toolkit is UI agnostic, alright, it's a tool that can be used in the server or the client. RTK query functionality can be used with a UI layer, with any UI layer, which is great, right? So it means that you can use that with Angular or Vue or Svelte, whatever you like. API endpoints are defined ahead of time, including how to generate query parameters from arguments and transform response for catching. You know, so we're going to define all of these endpoints first, and then include how to generate query parameters from arguments and transform response for catching. So in other words, it's like somehow you are using it, some sort of record as a way to catch those response. RTK query can also generate React hooks that encapsulate the entire data fetching process, provide data, and is loaded. Specifically for React, specifically for how can we now communicate with external systems in React. Okay. So for example is browser API likes or servers. Okay. So they provide you now these two properties that encapsulate the entire data fetching process. Or in other words, it encapsulates this particular logic, this Thunk, these functions that now have everything that it needs to do, except that when we pass a callback to get the data out of that, and then now create custom hooks, or in this case create now a way to keep track when the data when the state changed, and now make it available to your component or your UI. Holy moly, RTK query provides catch entry lifecycles options that enable use cases like streaming catch updates via WebSocket message after fetching the initial data. Interesting. Streaming catch updates. We have early working example of code generations of API slice from OpenAI and GraphQL schemas, right? We have early working example of code generation of API slice from OpenAI and GraphQL schemas. Finally, RTK query is completely written in TypeScript, and it is designed to provide an excellent TypeScript usage experience. But all of this is one of the reasons why I have to take a look now at this particular concept of the thunks and how we're gonna handle this asynchronicity and what asynchronicity means in concurrency, right? So now we have this layer, this foundation here, and a function that async read the functions, type string and callback function that should return a promise, and it generates a promise lifecycle actions type based on the actions. So now that we are able to understand the reason of why we're using is this thunk, async thunk, because it can be sync or async, all right? And now, all right, now let's take a look at an example of that. An exercise.
Calls for you to do the exact same thing as we did in exercise 1, except now we're going to use thunks. Okay? So if you open up the README in the EX2, we have the exact same setup. Should look the same.
Oh my god. Reload. Okay. There you got it.
Exercise 2 calls for you to do the exact same thing as we did in exercise 1, except now we're going to use thunks. Okay? So if you open up the README in the EX2, we have the exact same setup. Should look the same to you. No complexities different. But it is this line right here, line 23 in my code.
Okay. Now let's take a look at that. And that is here, right? Dealing with async with callbacks. Let me actually create now a new pen here, where now I'm going to do is this one. What you're gonna say is like, hey, this is now thunks. Okay. So async programming with thunks. Okay. There you go. I'm gonna do this. It's gonna now open up these themes here. As you get it. Where in the F is this?
That's the one I want to call your attention to. The getFile function is your Thunk constructor. GetFile needs to produce a Thunk. The question is, should your Thunk be lazy or should your Thunk be active? If your Thunk is lazy, are we going to be asking for files in parallel the way we want or not? If your Thunk is active, will we be asking for them in parallel? Okay? So first task is figure out how to make the Thunk. And second task, which you may actually want to do these in reverse order, is figure out how am I going to use those Thunks to sequence their outputs. So I'll give you 5, let's call it 8 minutes to play around with this Thunk. Remember,
Okay, what is the question?
if your Thunk is lazy, are we going to be asking for files in parallel the way we want or not? Is your Thunk constructor same to you? No complexities different? But it is this line right here, line 23 in my code. That's the one I want to call your attention to. The getFile function is your Thunk constructor.
Okay.
GetFile needs to produce a Thunk.
GetFile needs to produce a Thunk. Okay.
The question is, should your Thunk be lazy or should your Thunk be active? If your Thunk is lazy, are we going to be asking for files in parallel the way we want or not? If your Thunk is active, will we be asking for them in parallel? Okay? So first task is figure out how to make the Thunk. And second task, which you may actually want to do these in reverse order, is figure out how am I going to use those Thunks to sequence their outputs. Task which you may actually make the Thunk. Okay? So first task is figure out how to make the Thunk. And second task, which you may actually want to do these in reverse order, is figure out how am I going to use those Thunks to sequence their outputs. So I'll give you 5, let's call it 8 minutes to play around with this Thunk. Remember, we're not using any libraries here, we're just simply using the notions of function enclosure in a different way. You're not going to need any global variables here. So if you go down the route you did in exercise 1, you're doing it too hard. We'll see what you come up with.
Quick question. They're asking if you can go over slide 40 really quick.
I did go over slide 40.
Again, but did you review it?
Yes, I did review it.
Okay, sorry.
I can review it one more time. The function created on line 7 is hard-coded to know that the add async function is what it's going to end. Add async callback on line 11. First task,
Yeah, but
if
what
your
is the
Thunk is
task?
lazy, are we going to be asking for files in parallel the way we want or not? If your Thunk is active, will we be asking for them in parallel? Okay? So first task is figure out how to make the Thunk. And second task, which you may actually want to do these in reverse order, is figure out how am I going to use those Thunks to sequence their outputs.
Okay. How am I going to use these Thunks to sequence their outputs here? Like this, get file. How am I going to use these Thunks to sequence their outputs? So since this is now a function that has everything that it needs, right? Yeah, I was doing this too hard. Wait a single moment. It's like, wait a single moment. Wait a single moment. Okay. Wait a single moment. Okay. 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 So request all files at once in parallel. Okay. So by the time you call this, request all file at once in parallel. So by the time I get all of this, file 1, file 2, and file 3. Alright, so what do we do here? Especially is because here this get file is a thunk, and we're gonna make this thunk independent. How we're gonna handle the thunk? It can be synchronous or asynchronous. Alright.
And second task, which you may actually want to do these in reverse order, is figure out how am I going to use those thunks to sequence their outputs.
So the problem here is that how we gonna seek.
And second task, which you may actually want to do these in reverse order, is figure out how am I going to use those thunks to sequence their outputs.
How am I gonna sequence? How am I gonna use the thunk to sequence the output? How am I gonna output these thunks to sequence these actions? Because at the end of the day, this will represent now tokens. All right. Yeah, because here we go to represent our tokens. Okay, and those tokens is like so. How we're gonna represent is those sequencing action. So by the time this is whole, get file, you create a thunk. All right. So you create a thunk, and after all, especially an asynchronous thunk, you create now a thunk for that. So the question is, are we going to handle that? Okay. Because this is the tool that we have. What is the problem that we want to solve? Again.
If your thunk is late, file function in my code. That's the one I want to call your attention to. The get file function is your thunk constructor. Get file needs to produce a thunk. The question is, should your thunk be lazy or should your thunk be active? If your thunk is lazy, are we going to be asking for files in parallel the way we want or not? If your thunk is active, will we be asking for them in parallel? Okay? So first task, files is, should your thunk be lazy or should your thunk be active? If your thunk is lazy, are we going to be asking for files in parallel the way we want or not? If your thunk is active, will we be asking for them in parallel? Okay? So first task is figure out how to make the thunk. And second task, which you may actually want to do these in reverse order, is figure out how am I going to use those thunks to sequence their outputs. So I'll give you 5, let's call it 8 minutes to play around with this thunk. Remember, we're not using any libraries here. We're just simply using the notions of function enclosure in a different way. You're not going to need any global variables here. So if you go down the route you did in exercise 1, you're doing it too hard. Get file needs to produce a thunk. 23 in my code. That's the one I want to call your attention to. The get file function is your thunk constructor. Get file needs to produce a thunk. The question is, should your thunk be lazy or should your thunk be active? If your thunk is lazy, are we going to be asking for files in parallel the way we want or not? If your thunk is active, will we be asking for them in parallel? Okay? So first task is figure out how to make the thunk. And second task, which you may actually want to do these in reverse order, is figure out how am I going to use those thunks to sequence their outputs.
But what is the problem here, man? I don't...
If your thunk is lazy, are we going to... The question is, should your Thunk be lazy or should your Thunk to? The get file function
The get file function
is your Thunk
is your
constructor.
Thunk. So this Thunk is just this wrapper, is a function wrapper, is a function to get everything that it needs to get the value out of it. Okay? Alright. So in this case, because we want it to now is
Get file needs to produce a Thunk. The question is, should your Thunk be lazy or should your Thunk be active? If your Thunk is lazy, are we going to be asking for files in parallel the way we want or not? If your Thunk is active, will we be asking for them in parallel? Okay? So first task is figure out how to make the Thunk. And second task, which you may actually want to do these in reverse order, is figure out how am I going to use those Thunks to sequence their outputs. So I'll give you let's call it 8 minutes to play around with this Thunk. Remember, we're not using any libraries here. We're just simply using the notions of function enclosure in a different way. You're not going to need any global variables here. So if you go down the route you did in exercise 1, you're doing it too hard. We'll see what you come up with.
Quick question.
To produce a Thunk. The question is, should your Thunk be lazy or should your Thunk be active? If your Thunk is lazy, are we going to be asking for files in parallel the way we want or not? If your Thunk is active, will we be asking for them in parallel? Okay? So first task is figure out how to, judging from some of the looks on the faces in the crowd here in person, this was challenging, right? I promised that it would be challenging. I didn't want to let you off easy. But actually, you might kick yourself when you realize how stupidly simple this is. It just requires you to train your brain to think a little differently about these problems. So here's what I'm going to do. I'm actually going to solve the problem in reverse, because I find it easier to understand when I do that. So what I'm going to do is I'm going to assume that I have a get file function that does that magic, and we'll come back and figure out how to make it do that magic. But I'm going to talk about how I use the function. So I'm going to need to get something back from get file, and that thing that I get back is a Thunk. And I'm going to have 3 of them because I'm going to make 3 separate AJAX requests. So I'm going to call it th1, Thunk1 is get file file1.
You get file 1.
And th2 is get file file2. And th3 is get file.
So this is your
file
Thunks.
3.
Exactly.
Okay. Now that takes care of making the requests, but it doesn't take care of coordinating their responses.
Coordinating the responses.
So I'm going to coordinate their responses using exactly the way we know how Thunks work. What is a Thunk? It takes a callback, right? So I'm going to call th1 and give it a callback, which gives me some text. And for just clarity's sake, I'm going to call it text1. Doesn't matter what we call it. But I know that this callback will be called when there is a text1 to respond to. Does everybody agree with that? So
exactly. So this callback will be called by the time that T1
can simply output it at that point.
So now,
and then I know I can call th2 and pass in a callback.
And pass in a callback.
And at this point, I know I can print out the contents.
Exactly. But again, you are describing
then I know I can call
this
th3
as a
with
way
a callback.
to say, hey, as a way to describe this particular. So okay. So what is the endpoint here? So what is the outcomes here? Okay, I want you to now is run this particularly
and print out the contents. Oops. And finally print out my
here is
complete
coordinating is a response.
Okay. Now, if my Thunk was lazy, does everybody see why I would not be making my AJAX request in parallel? If my Thunks were lazy, if it did not make this AJAX request until that point, it would not make that request until after th1 had finished.
After the th1.
Is that a valid solution? Yes, except for the fact that it violates our principle of parallel requests. It would work, but it would not fulfill the requirements of the problem. So the requirements of the problem are going to ask us to somehow pull a rabbit out of the hat and create not a lazy Thunk, but an active Thunk. Okay? But if we do have an active Thunk, can everybody see why this is always going to make sure that they are responded to in the correct order? There's a couple of options here. If I run th1 and I print out the text for 1, and then I run th2, one option is that th2 is already ready to go. It already has a response. in which case it's right away going to call me with text2. That's one option, because it already had that one there. Another option is that it's not yet got the text2 ready, in which case I'm just going to keep waiting. But in either case, I know that once it does fire, I do have a text2. And once I get to TH3, there's only one of two options. Either TH3 is already finished, in which case when I call it, I'm going to get the value extracted right away, or I'm not going to get the value extracted right away, but I'll wait until I do have a value. So in all possible combinations, this expression, this nested callback expression, is going to sequence my output. And I don't have to worry about any kind of looping through some array or object to find stuff. I know that they're going to be sequenced correctly as a result. Does everybody follow me on that reasoning? Okay, one there. Another option is that it's not yet got the run th1 to somehow pull a rabbit out of the hat and create not a lazy thunk, but an active thunk. Okay? But if we do have an active thunk, can everybody see why this is always going to make sure that they are responded to in the correct order?
Yes.
There's a couple of options here. If I run th1 and I print out the text for 1, and then I run th2, one option is that th2 is already ready to go. It already has a response, in which case it's right away going to call me with text2. That's one option, because it already had that one there. Another option is that it's not yet got the text2 ready, in which case I'm just going to keep waiting. But in either case, I know that once it does fire, I do have a text2. And once I get to TH3, there's only one of two options. Either TH3 is already finished, in which case when I call it, I'm going to get the value extracted right away, or I'm not going to get the value extracted right away, but I'll wait until I do have a value. So in all possible combinations, this expression, this nested callback expression, is going to sequence my output. And I don't have to worry about any kind of looping through some array or object to find stuff. I know that they're going to be sequenced correctly as a result. Does everybody follow me on that reasoning?
And it's gonna be sequenced in this case because, well, that function has everything that it needs to do, and we just only is wait for the data to come back by using a callback. Okay. And by the time it's a th2, right? It can be either is or waiting for the function to be complete, or it's already okay, or it's ready.
Whether you realize it or not, that's a huge, massive improvement over our previous. And we didn't invoke any kind of library or any fancy thing at all. We're just using functions in a different way. This blew me away when I first realized that this was possible all along. Why on earth did I write so many years, decades of crappy code, not realizing how to use my tools more effectively? Because this is significantly more clean and understandable. It's not perfect, but it's way better than what we wrote in exercise 1. Now that I know that that's what I need to come up with, I need to figure out whether it's even possible to solve this silver bullet, this active thunk. So here's how we're going to do that. We're going to observe that there are two possible cases for every thunk. First of all, we know to be an active thunk, we are going to need to call the fake Ajax call right away. Does everybody agree with that? With the file URL, and we're going to need to pass it some callback that gets a response. That's going to have to happen right at the time we call get file. If that happens later, then we have a lazy thunk and we've failed our solution. Okay? We also know that a thunk has to return a function. Mm-hmm. And that function needs to receive only one argument, which is a callback.
Which is a callback in this case. Exactly.
Does everybody understand that reasoning?
Yeah.
So with this setup, we have line 24 and line 28 need to get bridged together in some way.
Okay. So this is now where the bridge needs to happen. One way we can bridge this is by using is now our closure here by saying is that, hey, by the time we get that response, okay, then we're gonna call the callback here. Yeah, by the time we get the response, but because I understand the problem here, the bridge here. So by the time we get this response, I will know what to do. Okay. I'll know what to do, man. Okay. By the time I have, okay. So what I can do is now, hey, use a text for that. So by the time that this response is done, we can now store in the closure the response, the text, and then pass that function with the proper data, which means that here now by the time you call the callback with the text, you're not effectively is passing the data that it needs to, because now this closure is it keep track this. So in memory is store that reference here. So this, by the time we call this get file, because it's now the reality here is that it's going to call now this function, that by the time that function is being called, because this is a closure and a closure holds a reference of this data, okay, now we are going to get that. Holy shit. The other thing is that how do we handle, okay, because this is one thing, okay, this is when this is when we need to call is our functions in this way, all right, in sequence. So we have to wait for that, and then we want us to print that all at once. The coordination problem here. The other is that by the time this function is called, okay, and we don't have that data, we need to actually pass the callback to the fake Ajax to now run with the proper response. Damn, son.
Either line 24 is going to run before line 28, or line 28 is going to run before line 24. Those are the only two possible outcomes. So we need to bridge the two, and we're going to do that by looking at both scenarios independently. So let's imagine, for an example, that line 24 runs first, before line 28.
Exactly.
So let's say line 24 has run. That means we got the response back, but we have not yet called our thunk. We're going to need to hold on to that response. Does everybody agree with that reason? So here's what I'm going to do. I'm going to, in my closure, have a variable called text. And what I'm going to say is text is equal to response.
Is equal to response.
Now, on line 30 now, which was the previous line 28, when line 30 runs at a later time, I have a callback.
Now, on this line, by the time it runs this function, that I have a callback that I receive here, and again, here's the storing is the reference of this. So here is the storing is the reference of this function in memory, and also the closures attached to this, which is the text, right? So by the time we now invoke this function with this callback, now it can pass is the text.
And I have some response text. So couldn't I just say CB text?
Exactly.
Does everybody see how I did that?
Yeah.
That's only one of our two scenarios, but I just want you to understand how we're bridging. In the one scenario, we're bridging by saving the text and then passing it into the callback at a later time. Okay? Now, let me back.
Using now this particular tool, the closure here, to actually is now store the value of this async response, right? And by the time that value is done, well, now you're gonna call this function. Now you're gonna execute this callback here with the proper.
Let's imagine that now instead that it's line 30 that runs first before line 26.
Exactly. So now if this function run first, okay, with the callback here, we need to somehow is to store. So if this function is getting called first, okay, we need to somehow is now is pass that callback to the fake Ajax. So we need to actually is store this callback reference, and then by the time this is done, run the callback with the.
So line 30 gets a callback, but we're not ready to use that callback yet, are we?
Exactly.
So what if we save it off? What if we say fn is equal to cb?
So we need to store this callback.
And then when this line 26 runs, I have a callback to pass my stuff to I can just simply pass response directly into fn.
Exactly.
Does everybody see that?
So we are using is now our closure as a way to handle this asynchronous, as a way to handle, as a way to coordinate is when is we gonna trigger or store is this value. Jesus fucking
So in
Christ.
either of those two scenarios, I have a way to bridge the gap, and that bridge is closure. Now I just need to put those two solutions together.
And because this function is going to hold this reference, right? This closure is going to hold this reference.
Okay? So what I'm going to do, I'll start back at scratch. What I'm going to do is set up an if statement to ask
Set
for
an
these
if
two
statement.
conditions. So inside of on line 26, what I'm going to ask is,
So
if
the text
fn has been set,
or if it's fn,
then I know that the other one has been called first, right? Because that's the only way it gets set. Which means I can simply call it.
so if this functions now has been set, then I know that this function has been called first before our function.
Right away with what I just got.
Exactly.
If fn has not been set, I need to save the.
Then if this function has not been set, then I need to is just set
The
the
response.
text.
Down here, we're going to do the reverse if logic. If
So if
The text
now
has-
the text has been
it's
set
been set,
first,
then I know.
okay, then I know that I need to pass this call, that I need to know to run this callback with this function, which means I have the value here.
No, I can just go ahead and send it to CB.
All right.
Otherwise,
exactly. Otherwise, then I need is to actually is run the callback, or in this case is that store the reference of this callback.
I need to save off my
Exactly. Store the reference of this callback.
callback.
Look at the pattern here. So, or you are triggering something, or you are now storing that to be letting on use it. Jesus fucking Christ.
A few of you had that. I had that mind exploding like,
What the fuck?
how has this been around? And I just never even knew it. Why didn't anybody ever teach me this in all my years of JavaScript? I don't need some library. I just need to know how to know. I need to know how to better
work with my tools much more
use
better.
the tools I already had.
And this is interesting because now in function enclosure, what it's doing is that I'm going to store this data, and by the time that they get in here, now I'm going to actually is store this. So instead of having is a global state, oh my god, instead of having a global state where you need to coordinate all of this kind of thing, you are now using is closure as a way to now hold the reference, and by the time they actually get the data, you now is update that internally.
I've looked and looked and looked for a
Jesus.
name for this pattern of bridging the closure of these two states. And really, I've asked functional programming developers and other people, what do I call this pattern? Nobody has any good name for it. So I just call it active versus passive, or active versus lazy thunks, because I don't have any better term for it. But when I discovered this a few years ago, I started using it all over the place. And in fact, I realized I'd already kind of fumbled upon that solution before in some of my earlier libraries, because I needed something like a promise before I had promises. And I'd accidentally stumble upon something kind of like this in the past, and then I realized, wow, that's actually a pattern I use all over the place inside of the various libraries that I write. So it's a more effective way of using the callbacks and closures that we already have in the language. And again, the takeaway, we have completely factored time as a state.
Exactly. So we don't need to actually is handling is time for this.
Out of the equation. We don't have to worry about it.
We don't have to worry about the time.
We set this code up once. This is like plumbing.
Exactly.
This is the program code that we write
This is plumbing. This is putting the infrastructure here, and this is actually the code that we
over and over and over and over again. And this is the part where we don't have to worry about time, because that part's already been taken care of for us. So it makes our code fundamentally easier to reason about.
The plumbering actually make when it comes to use that, easy to reason about. However, yes, it's easy to reason about that, but it doesn't look like synchronous JavaScript. Jesus.
Okay, so that's Thunks. The next step when we get back together is to understand how promises add on to that pattern and give us even more of a solution. Promises are not a replacement for Thunks, because inside of my libraries that I'm making promises, I use Thunks. Thunks are a thing that you can use. It's a very lightweight way of solving asynchronous sequencing issues without having to invoke some huge library.
But again, as long as this particularly, as long as the feature exists in the language, as long as now you have the ability of closures in other languages. So for example, Python closure. If I ask here now, oh shit, here we go. So if I ask perplexity here, right? So if I is JavaScript closures behaving the same way as Python closures? Both utilize closure, but they exhibit some different in behavior and implementation due to their respective language design. Here's a detailed comparison in closure in both languages. A closure in JavaScript form with an inner function retain access to the variables of the outer function. So it's a way of how you can store here the outer lexical scope of the variables, and even after the outer function has completed execution. This occurs because the inner function maintains a reference to the lexical environment. Exactly, this inner function is maintaining a reference to the outer lexical scope. To its lexical scope, allowing you to access variables defined in the outer function scope. Like this, right? In this example, inner function, by the time you call it, is now can have access to the outer variable in there. And not only that, if you want to perform here some sort of asynchronous operations, okay, by the time you call this, you can actually do this. Python closure. In Python, a closure is similarly defined as a nested function that captures the local state of its enclosing function. This is interesting. One of them is the lexical scope, which means that every variables of the lexical scope out of the function, where now this is to the local state of its enclosing function. Python closures also allow access to variable from the enclosing scope, even that the scope has finished executed. So for example, here you are now returning this function and then print this. So by the time you now do this, which is holding a reference for this inner function, all right, now you're gonna call that function reference and then have or run whatever the code has it is. I can have access to the actual outer lexical scope. Variables declaration. In JavaScript, variables can be declared using varlets or counts, affecting their scope and hosting behavior. Exactly. Python uses standard variables assignment with a specific keywords or block scoping. Standard variable assignment without the keyword or interesting. Python does not have JavaScript closure can lead to confusion with the this keyword, especially in the callbacks functions or method where this may refer to expected object unless explicit bound. Python does not have this issue, as it is used explicitly reference to object without context ambiguity. Okay. JavaScript garbage collection can lead to memory leaks if closure returns reference to a large object unnecessary. Python garbage collection handles closure differently, often cleaning up more efficiently due to its reference counting mechanism. Function factories. Both languages can create functions dynamically using closures. However, the syntax and idioms differ slightly due to the language design. So while JavaScript and Python closure behave similar in terms of accessing outer scope, variables and maintaining state, they differ in their handling of variable declaration, context this, and garbage collection mechanism. They differ their handling of variable declarations. Understanding this nuance is crucial for effectively using closure in either language. So they differ of their handling of variables declaration. Okay, handling of variables declaration. But again, it means that I just want to actually is check this, but with Python. Leave it. Do you save that? Okay. And now, what if I want this to is it's only web? Does it only do web? Codepen with Python. Okay. Great. So here, I just want this to now define is several inner functions, my friend. By saying is that hey, I just want this to define some variables here. Let's say outer variable. I am from outer scope 2, and this is now for 1. Okay, and then by this time I'm going to now call this, or in this case now alright, define is inside of this a function here. We say inner function 1. Okay, where now here is going to print f. It's print, right? Yeah, I don't follow. Okay, exactly. Spring outer value. So this print outer variable here, and then you're gonna print this outer variable 1, outer variable 2, and here you're gonna print outer variable 2 as it is. Alright. And here this will return is the inner function. Alright, where now this will return is now an inner well, as a way to make this much more cleaner, this will return now is the and now this will return is the inner function 1. Okay, it's gonna make this more contextually meaningful. And then 2. Alright, so I want you to now return is the inner function 2, putting here as a reference similar to this. So by the time you enter in here, this is a function here where you say, hey, inner function is gonna be called, which you are effectively creating a closure. What you are effectively creating is a reference in memory that don't have access to the lexical scope. The question is that, are you going to have access to a more nested outer scope, right? And by the time I call this again, function again, it's gonna do this. You say run, online Python beta. What the fuck? Hello? Question. Okay. Is this actually what is expected? Okay, it's not working. No problem. No problem. No problem. Online Python. Okay, online Python editor. Yeah, something lightweight, please. Oh, but everybody's now using is that. Enter either a name, a number. Okay, but now it's working. Okay. What about this? And that's right. And it say it says outer variable and it's an inner function 2. Oh, exactly. It's more like about syntax. Alright. And I say, hey, I'm from outer scope 1. And I am from outer scope 2. Interesting. So you're not creating this disclosure here. Exactly. That's quite interesting. I am from outer scope 1 and I am from outer scope 2. It's interesting. It's actually following is the same principle as it is. The subtle difference is now the value of how this is handled and the scope definition, variable scope definition. Okay, this is what I wanted to do here. Alright. Okay, cool. Good. Good, Jesus. So. Let me now is, in fact, open here the Codepen. Okay. And my activity here, or my work here, oh, this is what I want to use is this one, which is now resize mutation resize observer API. Makes a lot of sense. Resize observer API. Go back to this. Let me save this. Alright. And there you got it. Okay. Holy crap, bro. So, because what do we want here is to create now a thunk. This functions around this function that have everything that it needs to, so we can get a value out of this by passing a callback. Okay. In this case, it's async or in parallel. All right. So in this case, because we wanted to create thunks out of this, so we can say is, hey, this is now one thunk. Okay, you can say is now using let 2, they get value 2. All right, and let thunk 3. All right, in file 3. So the reason here is that because we want is to now is request all file at once in parallel. This is how can we handle this. Okay, and we're assuming that later on we're gonna set up that logic there. Good. But by the time that value arrives, okay, we want is to now is show them in the proper order as they come in, right? In this case, we have assumed we can set up these things. It's like by the time we call this thunk1, okay, as a way to handle this async operation or with this thunk. So by the time we get this, right, we need to pass this a function because after all this is an async thunk, right? So far so good. And this async thunk is when we're gonna get is the value here. It's gonna call this text1. Okay. So by the time that this thunk is called, we got now this text1. Okay. And then we want is to now handle is the next request or the next response here, because here we're dealing is with the response. So this will be is now the second response. Okay, we can say is now, hey, I want you to is, well, console log. So console log the text1. Similar for this. Text2. So by the time that we get the value out of the text1, okay, we either is or wait for the data to be completed. This is the two scenario that can happen here. Either waiting for this data to be completed, which means is that this callback is not going to be called, all right, or what by the time of the data that we get, now this callback will be called, so we actually show this text1. So in either of these scenarios, or this function waits to be loaded, this function now waits, or it gets the value out of this. So similar for this function here, text2, right? Where we say is, okay, now, let me actually put this one, that's right. So now, by the time now this another thunk happens, right? And this, by the time this another thunk happens, we call this function. We either is or get the value at once, right? Or we're gonna wait for that value to be later on showed. Similar for this text2, and the same logic applies to this. So now here, by the time we call the thunk3, it can either is or. So by the time we call this this is not text 3. So by the time that we call this thunk, it can be either quickly resolved, so now we get the value there immediately, or we have to wait until we get the value, right? But this is the two possible scenarios that can happen here. So because this is the two possible scenarios, and then we say, hey, console log complete, because this is the two possible scenarios that can occur, right? So look at this. Okay, so now let's going to actually handle is our coordination here. So it can be either or fired once, so fake Ajax. All right. It can be either fired once with the files. All right, and then we're passing as a callback here, which is now our function here. That by the time that we do, or by the time that these functions get that data, all right, we're now be able to have the data available, the response of this. Okay, and because we're creating a thunk, we need to actually create a function here that, because we're handling is async operations, we need to pass is now a callback to it. We are writing is async thunk. So by the time that value is done, all right, we need to do something here, or it either is by the time this function is called, we need to find a way to get the response here from this function. We need to actually make this coordination, or to close the gap between this. So one way to do that is by defining now here a variable, okay, that will be hold the response. So we can say, hey, by the time you get this, you say, hey, let's go to now hold the response. All right, and when this function is called, all right, which now holds a reference to the outer scope, if the text exists, so if we already get the data, then we can now execute the callback with this one, right? So the other thing that need to happen is that this is to handle is one scenarios. So which is by the time we call that callback, we immediately get that value there. But the other is that by the time we call this callback and we don't get this value, we need to somehow is to store this callback and then let it on call that, and then call when we actually need to do that, which is hold a reference of this callback. All right, else I want you to now hold a reference of this callback, store this reference here, and then check now here if the function reference exists, which means that, well, I need to now is exactly if that function exists, which means that function was stored first in our response. Is that function was stored first, okay? Which means that at some point by this time we need to actually call that function with the response. We agree with that? Right? If not, then we're just going to actually is call that response.
More.
Exactly. But this is not quite the logic here. And this is pretty French toast. This is blowing. Oh my God, this is blow up. Because by the time we run this, holy hell. So by the time we run this in our console, right? Requesting file, first text, middle text, the last text, and then complete. So this is huge, bro, because now we were able is to not only is abstract the time in our code, but also use our tool in a much more aligned way for that. God damn it. So this is when the coordination happens. The coordination happens. Holy hell. Or I'm going to store this text that I already have that and check if I already have the callback first. So what it's doing is coordinating is who was called first, okay? Who gets called first, and depend on that, you're now going to actually is call them with the proper data here. Holy shit! And most of the time, all of these are simple, bro. These are very simple. And that'll be all for this video. Take care. Bye bye.